called realestate.com.au. You might have heard of it. I'm part of the team for global infrastructure and architecture. We handle the infrastructure and architectural components of sites in Luxembourg and Italy. And we provide patterns for people so they could do whatever they want, but however still have guidelines to follow with regard to how they deploy their stuff or how they cut off their services. Our team is called Skynet, not to be confused with the antagonist of Terminator. However, we do kill services. That's kind of like a job description. We kill whatever's in the data center, move it out, and make sure it's out of our way. I'd like to start this talk by talking about the fates. They're kind of mainstays of Greek and Roman mythology, also known as the Furies, known as Moirai or Moirai in the Latinate, and they're in control of mortal destinies, birth, life, and death. And it's said that they can even dictate the destiny of Zeus himself. So they're kind of like a big deal. First one is called the Spina. She creates the threads that compose human life. Next one is called Lachesis. She is called the weaver. She measures the amount of thread that she provides before she weaves it into the fabric of human civilization. She decides if you're an artist or a poet or a soldier, philosopher, whatever. And the last one is called atropos, where the word atrophy comes from. Whenever a human life nears its end, she's the one who cuts it. She ends it. She's been called unturnable because people have said that her decisions are final. If she says life ends, then life ends. Why am I talking about it? We'll get to that in a moment, but as this is a DevOps group, I'm pretty sure that we're obsessed about the newest and shiniest way of deploying things, new software, new architecture, stuff that we could put in our build pipelines, new test suites. That's kind of like the cool thing about this space. It's a steady progression again and again, and every year somebody's coming up with something new, maybe every month. We're kind of at the belly of this huge shift to microservices, which is way, way easier for startups, but a lot more difficult for established companies who already have a lot of assets in the data center or already have a lot of software monoliths. I'm not here to bag on that though. I think making services decoupled or splitting them into pieces that can be replaced easily is a fantastic thing. However, we sort of came from having aluminum boxes to having M1000 chassis with multiple blades on it, and virtual machines, containers, and now people are doing Lambda invocations, millions of them. And last time I checked, somebody was, in our company, was making a SAML authentication endpoint with AWS using API Gateway, which doesn't have CloudFormation support yet, kind of terrible, but it's all right. But it's still a huge directional shift. It's quite big, and changing directions is super easy when you're in stasis. It's like just think of a boat that hasn't moved yet. If you change directions, there's not a lot of penalty. However, if you're already moving, you incur a lot of wasted space in between migrating your directions. Now, instead of having a singular boat, imagine a fleet, each with their own captain, and each with their own opinions. A friend told me once that out of 3 sysadmins, you're going to find 4 opinions, and none of them will ever agree. This is kind of the model that REA chose on as to why, Spotify model, that's why. People kind of like the squad model, and we decided to give each squad their own operations person as soon as we found out that giving people free reign to accounts and having them deploy stuff when they don't know what a seeder is kind of gets problematic after a while. So first, what is legacy? Let's give it a definition. There's common agreements on it, on what it composes. It could be a CentOS 5.5 box that you have somewhere out the back that nobody's ever paid attention to. It could be building your Koji repositories. It could have your M repo, and somehow it still works, still hasn't broken. You know, like you don't have to patch it for hardly because OpenSSL is sort of so outdated actually isn't broken. Or it could just be this really big thing. What we've noticed is a working pattern where some engineers try to make stuff that accomplishes everything that a software can. We have this JBoss monstrosity in the data center that we've had to cut. And for some reason, the engineer who was making it decided that, you know what, I'm going to leave my stain on this company, and they're going to know my name for years to come. And it's only later on that he would realize that people would say his name in anger. Or it could just be an outdated way of deploying things, or doing things, or cutting services that just, it's getting a little bit long in the tooth. Or it could be a combination of everything, This, given that our job was to basically deal with a shared infrastructure that every squad was still sort of somehow consuming from, we sort of had to make assertions at the beginning to make sure that we knew how the prey moved. We were going to take it down. We had to know the attributes, the general attributes of it, not just technologically, but socially as well, like why it existed in the first place. But the thing about legacy is a bit like metaphors for legacy. Everyone has a metaphor for it, and each one stinks. Each one's different. But for us, one of the attributes that we had was that legacy was a generator of angst. I'm saying angst, not pain, because sort of like it doesn't really manifest in broken technology pieces all of the time. It doesn't always manifest in errors. It's just a constant worry among like developers or ops that you have their lunch conversations and they say, oh my god, it's going to break at any given point, just watch it. So it's just a lot of wasted energy. The second type of legacy that we found was something that was woven into our infrastructure. This was when we were trying to pull out the set of JBoss monstrosity, and then we found out after talking to a lot of engineers that, oh yeah, if you move that, you're going to have to change this build, you're going to have to redeploy a couple of things. And it ended up that we had 5 squads that were involved in it, and none of them wanted to touch it. But nevertheless, it was critical anyway. But it's sort of like, it's the sort of thing where you get a new hire, maybe like a graduate come in, fresh face, it's like, I'm going to change the world. Comes into the company, he's like, you know what, I'm going to tackle this. And then 2-3 months later, you see him with like the sallow look on his eyes, and then he says, "Oh my God, it's like pulling a thread from a ball of yarn that never ends." They just keep untangling it, but there's more and more knots. And the third type was the type that cut us off from doing things. So we wanted to do a couple of cool things. We wanted to do push notifications as soon as things updated. We wanted kinesis integration. We wanted streams. We wanted data just as soon as it arrives. However, talking to like the other teams, we found out that there were like a couple of databases that relied on hourly crons to be updated. And that became like a little bit of a pain because when one component updates instantly and one component doesn't, what you have is a lot of broken stuff. But a lot of the things we found out as well during the course of actually trying to fix the problems that we had. Personally, I enjoyed it a lot. Learning is fantastic. If I came into it knowing everything that I could have now, it would be worthless, I think. So, but a couple of things came out of the blue. The first one was that it wasn't the first on the line of the things to be migrated. You would think that the things that would be most problematic to the business would be the ones to be first refactored or split into like a couple of pieces. But what we found over the time span of trying to migrate stuff to the cloud is actually, this is a generic hockey stick graph, but it greatly resembles what we actually have. So this will have to do for now. What we found is that the apps that were developed on most frequently were the ones that were actually migrated first. They were like the smallest pieces. And so it makes sense in retrospect. So what you'll find is a lot of the apps that have recent technological innovations are a lot easier to migrate over to the cloud because they're a lot closer technologically. On the tail end of it, what you'll find is the bespoke services, the artisanal code that somebody wrote and somehow still works and nobody knows because it's not documented and people have to somehow reverse engineer. And it takes exponential amounts of time compared to what is actually migrated to the cloud already. So the volume of the apps that you actually migrate over time decreases greatly. The second thing is that it's not always a bomb. The common characterization of technical debt is it's something that will explode on your production or whatever, but actually not really. What we found is that a lot of the apps that still remained had very predictable failure rates. It was so predictable that people actually integrated it into their workflow. For example, this is a screenshot from one of the components. Basically, it's disabling the toggle the next morning is a manual process. The disable for a toggle is a Perl script that just does a MySQL query that switches the bits 0 or 1. And no one had thought of putting it in a cron or actually fixing the app so you don't have to do that. But somehow people thought that it was a part of their work. It was just part of the noise, So you just kind of like learn to deal with it, but nobody fixed it. And the last one is sometimes it actually is a bomb. Sometimes that's what it takes for people to actually pay attention to it. A lot of the apps that we had worked for a long, long amount of time, and people will talk about it. We need to migrate off this instance. We need to stop using flat files for this component, or that NetApp disk, that NetApp volume is starting to get a little bit long in the tooth. And no one would actually action it until things start to change. And by change, I mean things blow up. And then people would say, oh, wow, maybe we should actually use Elasticsearch this time. The last part of it is something that's more of an attitude issue on our part. Because it's easy to characterize technical debt, or the people who make technical debt or create the technical debt as just villains, But it's actually counterproductive, because at the other end of the spectrum, the guy who made the problem in the first place, and in this instance, the guy who created the JBoss monstrosity that caused all our problems, was actually just trying to solve problems where technological solutions didn't exist during the time. And I think it's really important to remember that, because whatever we make right now is ephemeral, as much as the infrastructure that we're making it on is increasingly becoming more and more ephemeral in itself. In a year, developers will complain about it and give 6 months after that, and it will be treated as legacy to be replaced. And that is the way it is. That is the technology space, and kind of a sort of acceptance on our part that is the way it goes went a long way morale-wise. Because the thing that people don't tell you about trying to fix technical debt is it's a very exhausting process. You're basically dealing with old technology while everyone else is working with Lambda invocations, or they're making their Docker containers, they're making their registries and whatnot. And here you are dealing with old VMware virtual machines, or trying to migrate volumes out of NetApp disks for people to actually use object-based storage, and it's kind of just like a mess, and it's really exhausting. But that is the way it is. That Docker registry that you made, some kid is going to come along in 6 months and do it faster and better and more awesome than you, and that's the way it
Fire
goes.
that kid.
Sorry?
Fire that kid.
Fire that kid? Oh, okay. Well, what now? I mean, it all sounds problematic and whatnot. But I think the key to it is keep making stuff anyway. A lot of people, I've seen instances where a lot of offshore developer guys actually get a sort of paralysis from making stuff, and they get stuck between this loop of, I gotta make this perfect, I gotta make this bulletproof, I gotta make it work so it works for as long as it could. But the thing is, in the technology space, the right solution that you have for now may be the wrong solution in 3 months, and that is totally okay. However, if you do make stuff, do specify your bounds. As my friend says, the new legacy is bounded legacy. The new legacy is limited so that it has a limited blast radius when it doesn't explode in your face. the easiest and most lightweight way that I could sort of explain this is how we kind of assembled our Contad wall. So instead of having an actual Contad wall, we just had an XY graph. Criticality versus complexity, where complexity is the amount of teams, amount of services touched. And this is a very rough mind map, so it doesn't actually have any numeric values, so we just put stuff here. So for example, this is migrating your front-end pages to S3 and then putting the Akamai endpoints. Relatively critical, but also a little bit easy. Because, for the most part, a lot of it is just pulls to S3 and then you test your endpoints or your ELBs and make sure that your actual, the checks that you have actually do work, your smoke tests, your ABs, that's fine. Then we had the issue of logging, centralized logging, which I'm finding is becoming more and more the volcano pit. You just throw more and more money at Splunk until they give you more gigabytes, which is becoming fantastic. It touches everyone, however, it's still a little bit critical. And this is more my internal bias speaking than anything. Is the internal CA system. You have a trusted root and intermediate and internal CAs for your certification system so that everything can talk through HTTPS. And this is the line of too bigness, where anything after that gets cut into pieces. So for the issue of logging, we've kind of done the same thing. So we cut it so that it doesn't belong in there. Move it over. So the issue that we had previously was that our VPCs were sort of forwarding all their traffic to the Splunk indexer that we had in the data center, and it was becoming a lot problematic because when we wanted to migrate stuff, you had to change a lot of endpoints, a lot of the forwarders that they had. So what we had instead was we provided a pattern so that people would have intermediate forwarders on their CloudFormation stacks so that it was always there and it would point to the instance that was active during the time. Second thing that we had was we actually split our indexers. I know centralized logging is sort of a really big thing in the DevOps space, but in this case we kind of had to do it because IPS, IDS, any equipment that you had in the data center kind of spits out a lot of logs. And over time, what you're going to find out is you're paying for the salaries of a whole team of Splunk people. And this tertiary change that we had, just to let you a couple of things, was we noticed the pattern that we previously used was VPC peering. So we declared the route tables in CloudFormation, and that is how they would talk to each other. However, we found that it was counterproductive because anytime you were trying to change something, you would have to change the two of them. And so instead of using VPC peering, what we had instead was the CA system coupled with the SSL over the internet. The third one is, I think, the most interesting one because it's not technological as much as it's social. You have to identify and actually know when to kill the services that you do have. As soon as they're causing problems, just nip it in the bud before it grows and grows. However, I understand that this is really difficult sometimes. I've worked for several companies where it's really hard to sell paying technical debt as an actual priority. Because a lot of it manifests in the back end. Most technical debt manifests in the subsystems that you have in place in the background that sort of like chew up your data and make sure that everything's in place. And explaining that to people kind of really hard unless they're actually aware of like what's happening. And the biggest change that we've had as part of the paying off the technical debt process is we componentize the actual teams themselves. So this was an experiment that was only supposed to last for like a couple of months. As I mentioned before, we have multiple squads, each with their own ops team. And what we found was that over time, it actually really, really helped because it allowed clear visibility into whatever everyone was doing. There was a specific person assigned to specific units or specific services in the business. And the only thing that they were concerned about during the whole day-to-day was how the other squads will consume from their service or how they will feed other squads. in a lot of ways, it mirrors the microservice kind of like deployment paradigm. It encouraged good practice because nothing pisses off an ops guy or like makes him happy or both than seeing another guy do it better. When somebody solves a problem in a lot cleaner way, it's kind of inspiring, a little bit annoying if it's someone really young doing it, but still really cool. And the last thing is that hot data was no longer a thing. So what we had, one of the components that we had was a huge database that supplied a lot of the units in the business. And people didn't want it. So when we split the squads, when we split the company into squads, what we found was that people were trying to pass off the database. No, it's yours, it's yours. But when it came to consuming from the actual service, everybody was game for it. Nobody wanted to handle it. But as soon as we actually had ops people dedicated to that specific unit, there was a delineation. And I'm sure we're all familiar with Conway's law. So yeah, just to reiterate again, organizations which design systems, they produce designs which are copies of how they communicate. And that is what happened with us when we split the team, when we split the company into squads, each with their own ops teams. It mirrored the exact environment that we wanted to happen in. And in closing, I'd like to sort of note, that not a lot of what I say is actually novel or new or whatever. It's something that we're all kind of aware of. However, like to me, there's a huge difference between being aware of something or being mindful of it every time we build something new. And that made all the difference for us because it changed the way we looked at things that were old that we had to fix. And instead of something that we just had to stamp our feet in and sort of crumble towards, it became something that we kind of looked forward to. Because that's the space that we live in, everything's in flux, there's something new every time, and we're tech people and we drag stuff kicking and screaming into the future. Thank you. Also our background. So. Any questions? Any questions?
I do have one question, which is when you were identifying legacy components which you believed were good candidates for decommissioning, basically.
Yeah, so decommissioning, sorry.
But my question, I suppose, was did you have to provide any kind of evidence of like the value or the what you to the business to say, if you let us turn this off, it saves us this much, or did you have to quantify that somehow?
That was sort of like not something that we actually had to quantify as much as it was an effect of like splitting the company into squads. So once actual units of people owned specific units of the stack that we had at the data center, then the justification actually didn't take place that much because sort of like they had something that they had to take charge of, they had something that they had to move to the cloud, and that was it. Any other questions? Yeah.
What was the gist and the resolution of the puppet versus chef contention?
Yeah, so it's actually interesting because each squad does something differently. So we have squads that build their own weird Python deployment module. I'm not sure if you guys have heard of Harpoon. So it monks CloudFormation templates, pushes them to the cloud. We have squads that are pure CF. We have squads that use Ansible, and we have one, sort of like this, one squad that used to be that actually like to do stuff in Babushka, but sort of like, thankfully they're gone. Which is fantastic. And but otherwise, a lot of people create their own tooling, to be honest. So yeah, it varies a lot.